The world of astronomers has been waiting for breakthroughs that are so great that they can shift the path of history. A clever innovation with the unrivaled power to go millions of kilometers beyond the Earth and unravel huge secrets of heavenly bodies hitherto unknown and unexplored by mankind. NASA's disposable telescope, constructed by James Webb, was deployed to space to uncover and bring back discoveries. NASA's incredible discovery with James Webb Telescope will change everything. What can we expect from NASA's insane telescope? What kinds of discoveries will it make? How easily replaceable is the James Webb Telescope? Stay tuned as we closely examine this one-of-a-kind telescope. The James Webb Telescope is sailing to its final orbit around the Sun, a point in space more than 1,000,000 miles farther away from the Sun than the Earth. It is situated at a point that enables the telescope, the sensitive and most expandable craft or instrument ever put in space, to keep all the important and exact sources of heat and radiation, be it the Sun, Earth, Moon, or the telescope's electronic and attitudinal jet. Safety to one particular side of its tennis court side heat shield. A whole lot of things have to work perfectly. The heat shield is a stack or combination of 5 incomprehensible and unparalleled thin sheets of materials, called kapton. The thickest of them all is just 0.05 of a millimeter thick, which enables it to have uncountable points of failure in its unfolding machinery. The primary mirror, which signifies the most important first part of the telescope mirror ever deployed into space in an individually mobile segment, must couple up perfectly for the telescope to capture the anticipated glances or view of the beginning or first universe. What are the reaction wheels? There are dozens of mechanisms that move in motion and twist the mirror path, a unique chilling system, a final burn delivering the telescope into its primary orbit. Everything concerning this unparalleled telescope has to work perfectly because there's no presently advanced spacefaring technology that will allow NASA to send a human to get it fixed if something goes wrong. Webb Telescope is an outstanding probability, or you might say it's a gamble to either win or lose. It is a $10 billion design. So complex, complicated, and yet so promising, it appears more like an over-provocation against creation itself. Worryingly for the superstitiously sloped machinery, everything seems to have gone excellently fine so far. The launch from Earth was so accurately aimed that NASA announced that the telescope will only require less fuel for the correction burn, confidently and strongly the 10 years estimate of Webb's operation by more years. Shortly after Webb's perfect commando launch into space during Christmas, Michael Kaplan, a former NASA engineer, who headed the space agency telescope planning in the 1990s and was one of Webb's initiators, interviewed in a video from his home in Colorado on how Webb has already pushed the boundaries of humanity's engineering capabilities and would precisely soon increase our knowledge about the universe and where space travel is headed. According to the Times of Israel, Kaplan, 66, has spent a career in aerospace, for more than 10 years back at the United States Naval Research Lab in Washington, where he worked on space-based radars meant to counter Russian ICBMs, to NASA, Ball Aerospace, the Colorado company that built Webb's currently famous honeycomb mirror, got employed at Boeing and helped work on planetary probes, and finally, in the Israeli Space Agency and aerospace industry. Kaplan traveled back to the United States in 2015. He has worked on new space missions and weather satellite systems in companies such as Raytheon. He is currently the vice president at Belkin, which happens to be a major engineering company, most times given contracts by the government. He was asked mainly what gave him the purpose and courage to build such a telescope. According to the Times of Israel, he said, when Hubble was launched in 1990, people were protesting at the launch pad because, funny enough, they were afraid Hubble was going to see God. He further explained that it was more like he was behind the cloud and Hubble was going to expose him. However, Hubble was limited by its aperture size, the sensitivity of its detectors and instruments, and the fact that it wasn't very cold. He stated that most people didn't realize that Hubble could only observe about 35% of the time. It spends the other 65% of its time dodging or running away from the Earth, Moon, and Sun, because it is important not to allow the light from the Earth, Moon, and Sun to get into the telescope and destroying the mechanism or instrument. It also can't see a longer wavelength than the near infrared. How it works is that the oldest bit of the universe appears to the scientists shifted far into the infrared, meaning that the oldest bits of the universe, whose light has been traveling the most through the ever-expanding space, and so whose wavelengths have stretched the most, will appear to the scientists shifted far into the infrared. Kaplan further explained that a group of scientists called HST and Beyond, headed by Alan Dressler at the Carnegie Observatories, asked, "What do we do after the Hubble?" Kaplan was the head of advanced programs in astrophysics at NASA at that particular time. The job apportioned to him was to plan future telescopes, so we met with the committee and gave a presentation on the present state of technology. The committee stated, however, that they intended to search for baby galaxies and needed to launch an infrared telescope equipped with a 4-meter primary mirror. Hubble's primary mirror was 2.4, so he asked himself, why 4.0? Because that was a mirror that could only be fixed in our current rocket. Amazing, right? What's more fascinating is that when you add up all the needed mechanisms and put it all together, the overall problem of having a complicated and complex instrument working perfectly at 100% reliability was initially a challenge, and the only way you could skin a rabbit properly is by practice. No one had ever designed and tested something as complicated as this in space before, Kaplan said. Basically, you mitigate a moving part by having a backup. If a primary motor fails, you have another motor, but not everything can have a backup. When you're unfurling a line that's putting and creating tension on the sun shield, you can't have another motor on a piece like that. A common notion amongst Webb engineers is that, to the limits of our knowledge as humans, we have analyzed and tested just about everything we could. You put the greatest minds on it, you have a plan, and then you just gotta have faith and believe in your heart that it's going to work. So amazing, right? In the interview, Kaplan stated that the future of space is commercial. Throughout his life's journey until now, he has noticed 2 important changes in space. The first is the reduction of launch costs that started with SpaceX and their Falcon 9 rocket. In the past, to put something in space, you were estimating roughly about $150 to $200 million per launch. Presently, flight to space would be within the range of $50 to $60 million, reducing the cost 4-folds. What made this birth this massive possibility? It's basically because of the rocket's reusability. Elon Musk has started revolutionary agility in the space industry in general. The next thing Musk did was design and manufacture engines that wouldn't work at their maximum capabilities. Kaplan added that if you want to make something reusable, you can't stress it to its limits, like you can operate it at about 75% capabilities, which guarantees maximum success, he continued. I remember when I was sitting at a cafeteria at Boeing with a bunch of Delta engineers when Falcon 9 had its second launch failure in March 2007. They were all saying, he will never get there. Boy, were they wrong. NASA is going to be retiring from the International Space Station soon, giving way to more commercial possibilities. Various space stations and facilities would be built in space decades from now. Much of the infrastructure to build the follow-ups to Webb will be available. Many private companies would be building infrastructures in space. NASA and other space agencies won't have to pay for the development of capabilities. There is a high possibility that after we start processing another mission after James Webb, robotics would be the key. It is that telescope, with a primary mirrors of about 15 to 20 meters, that will be manufactured in the nearest future. NASA's insane discovery through its telescope by James Webb of new planets and information about the beginning of the galaxy, new heavenly bodies in the galaxies, and other mysteries of the universe will transform the space knowledge of the whole world. What do you think about NASA's telescope? Do you believe the telescope will be able to complete its job as quickly as possible without encountering any complications? Remember to leave your thoughts in the comments section below.